renewables integration. So not sure who is presenting. Is it you, Teja and Sai, or it's your own?
Okay.
Thanks.
Is right through protection function. Yeah, myself Teja from applications team. Today I'm going to give demo on this under voltage right through protection function, which is going to be released in 227 in 670 product. So I start with like what is UERT and why it is needed. So UERT basically means like under voltage right through. It is the capability of the generating unit to remain connected to the grid when there is a transient under voltage condition happens. So why this UERT is needed during like transient falls where there can be seen like voltage dip for short period of time. During that time, like our protection functions may operate and disconnect the generating unit from the grid. So this will lead to a lot of stability issues in terms of grid point of view. So in this kind of situations where the generating unit is like very much important to need to support for short period of time when there is a shorten fault. So that's why this UVRT is important to stop the protection functions for short period of time when there is this kind of transient conditions. So I'll jump on into this grid codes. Various country grid codes are shown here. You can see European grid codes and like other rest of the world grid codes where the UVRT curve is fixed for uh, like TSO. Like so, these are examples of rectangular UVRT characteristics, and these are like polygonal UVRT characteristics. So it depends upon the country to country, like where they have based upon the system, like they will design the UVRT characteristic where they will allow the voltage dip for this set amount of time, and they have to trip if the voltage dip is continuous more than this time. So basically, what this curve means, like if, for example, if you take the blue curve, like when there is a voltage dip happens, like for short period of time, for this much time, you can see here somewhere around zero point 0.2 seconds. So it should not trip, it should not disconnect from the system. So if it persists more than that, then it should trip. So that is what it means. So in this, I have shown like again like TSO requirements in various countries and standards from IEEE and IEC where they mention about this under voltage right through. You can see this LVRTC characteristics like where it is mandatory and where which curve is used, polygonal, rectangular. This SMTSS and MMTSS is particular to some local TSOs where they do some study based upon this. SMTSS is single mission infinite bus transient stability study, and MMTSS is multi mission systems transient stability study. So some local TSOs they do this study and they design these characteristics accordingly. So apart from that, we have this most of the places they use polygonal and rectangular, where the curve look like this. Rectangular will be looking like this, and polygonal will look like. So coming to our protection function, which we are offering here, this is how it looks like. So we consider voltage input to decide like we need to monitor voltages right in order to block the protection functions and trip and provide trip whenever the voltage cross goes to the trip region within the specified characteristics. So for that we are taking voltage input and we are providing trip phase wise start and fast reset. Will be going through that in next slides. And this also ready also this STDR is a binary coded start. So I'll be explaining further on fast reset and ready in further slides. So this RDPTV basically have this, actually these, I forgot to mention this. These are number of points in the curve actually. If you consider any curve here, if in dark blue curve, like number of points are 2. Like that, if you see green curve here, number of points are 1, 2, like here also 2. Like that, we have a limit of number of points we are offering, that is 15. Up to 15 customer can set, and for 15 we need to provide 15 voltage set points and 50 time set points. Yeah, this function works in works for both positive sequence and phase to phase and phase to neutral voltages. It consider any one of it based upon the setting, and it operates accordingly. So this is how the setting page looks like, and so you can see here number of points it can be set up to 15. Based upon that, that many pair of settings will be visible here. Here, for example, I have set up to 6. So you can see 6 pair of settings for voltage and time. So coming to this, few settings I will explain here, like they are very much important. I have shown one output ready. So before even indicating there is a under voltage condition, we are checking whether the voltages are healthy in initial state or not. For that, we check whether the voltages are like rated or healthy. If it is greater than U start level, that is considered as healthy state, and that has to happen for this set time, minimum start value time. So if the healthy voltage is maintained minimum for this much amount of time which is settable, then only we'll start looking for under voltage condition. So that is the meaning of ready. Once this condition satisfied and ready becomes high, then we'll the function start looking for under voltage condition. So that is it. And yeah, coming to this voltage operating quantity selection, there is a there are two settings. One is connection type and measured voltage setting. So where the customer can choose between positive sequence and phase to phase or phase to neutral bit using measured voltage selection. Among phase to neutral and phase to phase using connection type, it can be chosen operating quantity. Yeah, that is it. And these settings, I'm going to show further on, like using the examples, then you will understand what is the meaning of this voltage level 1 and recovery time 1. Yeah, there is one more logic inside the function. There is one more feature, that is fast reset feature. That also I'll explain later. It is easy to explain using the example rather than just settings. So what is like use of these settings? Like if using this set of settings, we can draw this curve. This is completely customizable. So customer can set rectangular curve or polygonal curve like based upon these settings. So you can see here, for example, I have shown by taking 6 set of settings. So number of points considered here are 6. So you can see here voltage level 20 and recovery time zero point 0.5. That means from the moment of under voltage detection, you can see here the way the points are considered. If the voltage level is varied like this, you can see that you can achieve the slope. If you want slant horizontal line, you have to maintain the same voltage level for next voltage, then give the time. Like that you can achieve horizontal line or line with slope. So both can be achieved like in the way as shown here. So like this, with the settings provided, you can customer can set any way like based upon the grid codes in that location. This is one example of UART curve. Yeah, here I will explain one more thing, like uh, how when it operates and when it won't operates. Like this function provides block to protection functions, and when it provides block, whenever under voltage happens and the curve is lying in this region, and if the voltage is recovered within this region, then start will be provided from this function, and it will block the protection voltage under voltage protection functions, like protection functions which will be working based upon voltage, and that too like only under voltage functions. So those functions will be blocked when there is under voltage condition happens, and if the voltage recovers within this region, then this protection functions will be blocked up to this duration, how much ever the curve is set. So that duration only these protection functions will be blocked. In another case, or like one more example, if the under voltage condition, like if the fault happened and the fault persists and voltage is down continuously, you can see that voltage goes to this region at some point. So whenever that happens, if it enters into trip region, this function provides trip. So it means that is a fault condition. So this is how like both happens. One is blocking of protection functions, one is operation from this function whenever the voltage enters into the trip region. So these are the two operations. There is a one more feature that I told I will explain. This one fast reset logic. When like the that is having these settings: enable fast reset and U fast reset and T fast reset. These three settings. When like fast reset logic can be enabled using this enable fast reset, and once it is enabled, these two settings comes into picture. When there is an undervoltage situation happens and voltage recovered immediately, and that too it is settable actually, we will set that value and we'll set time also. If you go here, if voltage dip happens for a very short amount of time and it recovered, so we don't want to block the protection functions up to this much time, up to the curve set time. So we want to reset this curve. During that time, if the voltage recovers more than this within this time, we'll reset everything, start trip, and we'll reset every output of this function, and we'll start looking for another voltage dip condition. So that is one good feature in this function, that is fast reset logic, that can be enabled using enable fast reset setting. So coming to this logical diagram, you can see here operating quantities here considered like pass to sequence, this phase to phase and phase to neutral quantities that can be actually these between phase to phase and phase to neutral can be chosen outside, like using connection type. Whichever the connection type selected, that input comes into the function, and based upon the positive sequence setting, measured voltage setting, either positive sequence or the three phase quantities will be considered. So when one more point here, when positive sequence mode is considered, will show only start and trip from this function. Phase wise start will be disabled from this function because only one operating quantity will be considered to monitor whether there is an under voltage condition or not. That's why we'll provide only start for the protection functions to block in case of positive sequence mode. So for other, all three phases are considered and will monitor all three phase voltages. When the phase voltage in initial condition, when the phase voltage is greater than the U start level, then we'll provide ready. Once ready is high, then only we'll start looking for under voltage condition. So whenever ready is high and under voltage condition happens, we'll provide start immediately. Once start is high, then we count the timers actually in order to see whether the our voltage is entering into the trip region or not. We want to like count the time from this point. From this point, we'll start looking the voltage over time. So if the voltage is this much here, it is fine. If it is same here, it is fine. Once the same voltage is here, then it is not fine. It comes under trip region. So that's where we provide trip from this function. That's why we need to count the time. So yeah, that is how we'll provide trip whenever it enters into trip region. Trip will be provided based upon as a pulse based upon the setting T pulse trip. So like if it is 100 millisecond, trip will be provided for 100 millisecond, like that. Yeah. This all these binary outputs can be blocked using this block input and this block VTSU. This is from fuse failure, where the voltages are during fuse failure condition, we don't want to consider those voltages to provide start and trip. So during that condition, we'll block this function. And when CP open is there, that condition also we don't want to operate this function, we'll block this function. Yeah, one example I have taken here to explain the operation of UVRT. So you can see here in one of the phase, voltage dip happened, and this is actually fault condition. This is not a transient condition. You can see here voltage dip happened, and immediately once it is lower than the U start level, the start L1 phase wise L1 and general start became high. Once it crosses the curve, once it enters into trip region, trip will come for the duration of T pulse TR. But start L1 will not reset up to the end of this curve until unless there is a condition if CB open command is received from the CB status. During that time will reset actually. So that is how it is designed. If this one is not provided inside the like it is not connected, then it will be prolonged until unless it sees the healthy voltages, so it won't reset at all. So yeah, that is how it works. This is an example of fast reset logic, where you can see the voltage dip is seen only for short period of time. Here the U fast reset is set as 90%, same as U start level, and T fast reset is set as 1 second. That means from the starting of under voltage condition, we'll look for reset condition for 1 second. So within 1 second, if the voltage is recovered, then we'll reset the start. From this point onwards, we'll again start looking for under voltage condition. So we don't want to block the protection functions up to this time. So that's how we can have an advantage to see for another voltage dip, and we can start the curve from there. Yeah, this is the overview of this function. I will show the demo. Like before that, if you have any questions, you can ask now.
Here's Peter speaking. Quick clarification on your statement you did before. You said you will block the other under voltage functions. So it's the engineer who's using ACT does not need to take the start output of this function and connect this to the block input of other voltage functions? Or is it actually done by the base off there or something like this? Just to
No,
understand whether the
yeah, I understood your question. It has to be done in ACT level. It is not internally connected. We need to
okay.
connect.
So it's a logic. Okay, it's a
Yes,
logic I
yes.
implement as an engineer. Okay, fine, good.
Yeah, if there is no further question, I'll jump on to demo. You can see here how this RTPTV can be connected from voltage SMA, where the voltage is connected to U3P. So I have taken block also to just show like how block also works from binary input. I'll show setting page once. You can see here, you can set this up to 15. Like I will show changing this. If you set two, only two set of settings can be set. Others are disabled. So that is also like it is easy for the customer to like not touch the other setting if based upon the number of points he has selected. Yeah. Uh, Here for the example I will take only 6 point here. So the graph which I have shown, those only I have set here, except this recovery time I have set 5.56 5 seconds, because in order to change the voltages within that time, like we need to see how the operation is happening. So that's why I have taken more time here. So usually this times is very less actually in real time. For explanation purpose only I have taken more times here. And this minimum start value time also I have taken 5 seconds. That means once you apply healthy voltages greater than the U start level for 5 seconds, then you will see ready. And like initially I have disabled this fast reset logic. I will explain using face to face voltage. It is easy for explaining. That's why I have considered face to face. So I'll I'll show what are the values we are feeding now. So right now we are feeding healthy voltages. Like I don't want to feed healthy right now. I will feed zero voltages and apply block. So this is a when you initially switch turn on the function. So once healthy voltages are read, that means like rated voltages are read. Uh, you can see star ready will become high after 5 seconds. You can see becoming one after some time. Yeah, that's I intentionally put 5 seconds so that I will show like after 5 seconds it is becoming high. So after ready, once ready is high, then the function start looking for under voltage condition. So here initial U start level is given 90%. So I apply 85%. So that is under voltage condition basically. So I'm applying 85. In first example, I am keeping 85 continuously. So you can, I applied 85% of voltage in UL1. You can see start immediately, but trip after some time only you will see. Like it's still zero. It is one now and it is resetting. Why it is happening? Like if you go to the curve here, I am providing 85% and keeping that 85% continuously. So it is entering into the trip zone at the end of the curve. So that's why after a long time we have seen like trip and trip is resetting after triples TR that is set as 2 seconds. That again to show for some time. So it trip came for 2 seconds and it has reset. But I maintained 85%. So that's why start is not resetting at all. So there are two conditions to reset starts. Both has to satisfy. One, the entire curve has to complete. The other one, at the end of the curve, the voltage should be higher than last recovery voltage. That is 90% in this example which I am considering. So it is not greater than the 90%. So that's why these are still high. So I apply rated voltage again now. You can see all are resetting now. So the function is set for another like looking for another under voltage condition. That that's how it works. So one example I want to show here is like how the fast reset works. So I will change the mm, first setting. So fast reset is off right now. I'm turning on. So I'll put T fast reset as 2 seconds. Like within 2 seconds, if the voltage has recovered, then start will reset immediately. It won't even wait for the curve to end. So you fast reset 90%, that's fine. Here again, I will apply under voltage condition. Immediately I will recover the voltage from 85% to 100%. You can see here I apply 85%. Immediately I applied rated voltage, but it missed to apply within 2 seconds, I think. that is the problem with like this short period of time. Oh, I should. So it's better I'll give higher value.
Maybe you connected DR you can show.
I haven't connected. It's a bit where instead we can just change the setting here itself. Yeah, something is wrong here. I should come back. Yeah, let's see now. Yeah, you can see immediately once the voltage recovers, then start and start L1 are recovering. The voltage has to recover within the set time, T reset time. So, yeah, for example, I have taken this much time here duration. Actually, in practically, like that time will be within 1 millisecond. That I can't show here. That's why I have taken those values. So, yeah, any questions now? Yeah, one more point I missed. Selected as face to face and face to neutral, then only will show these all three outputs. When the positive sequence mode is selected, positive sequence voltage will be the operating quantity. That value will be shown as UL1 here at UL1, and the description is provided as like either UL1 or this positive sequence based upon the settings. It is clear with the description. Yes, yeah, someone is asking question.
There's Peter speaking again. Is there a graphical preview of the parameter setting, like in the distance protection, that you can see the settings over the time?
Actually, this is not having in this protection. This function was developed in Ref 650. There would actually this came with GPST requirement. They were working on dynamic GPST so once the dynamic GPST is available, I'm not sure whether that is independent of the product or like I think it is independent of the product, right? Like if
It
that
is
is a
independent, yeah, and it will be it being developed, so it will not be part of this 7 release, but in one of the upcoming, and I'm not sure in which one exactly, but during this calendar year, I think it will be available in PCM, but not associated with this release. So yeah, we're working on that, Peter. And basically what they are doing is this, what they just said is dynamic support for graphical visualization of the function. So there will be more function supported as well, like differential and stuff.
Exactly. So I think it's more like a family feature that you to support the understanding of the parameter setting, that for the more complex functions where you have this kind of parameter changes over time or these kind of things, it would actually make sense to provide this.
Exactly.
But if it's coming, it's okay.
Yeah. It's on the roadmap.
Hello, can I mention something?
Yeah, go ahead, Nemanja.
Okay, one more thing related to parameters for the recovery time. When we see the graphics of the coordinates of all the points in diagram, can you return to the, yes, this recovery time 1, recovery time 2, and others. These are times definitely should be explained in the manual exactly and clearly for the customer to know that, for example, recovery time 2, 1 second is not the absolute coordinate of the time from the time of fault. This is a recovery time to 1 second from the recovery time 1.
Yes, and
yes.
this with this figure, customer can understand, right? Like,
yes,
this is provided in user manual.
My mention is only to clearly that explain, because it could be how to say, hard to understand for the customer, that thing.
Yeah, especially because you're putting the recovery time in text at the point when in fact you're describing the segment.
Yeah, someone will expect maybe absolute coordinate of that point, but this is not absolute coordinate from the fault instance.
Because depending
I mean, when you put some values at the point in text, you're marking both the x's and y's of that point, which you do with the y's, but not with the x's. And this is not right. If you want to describe recovery time, you need to put it at the segment.
Yes, agree.
Okay. Yeah, we can just provide that. We can mark that segment by indicating this 0.5, like this is 0.5, this from this 0 to 0.5, from this one is 0.5 to 1.5. Like there's some indication, it is easy to understand then. Yeah, I'll take that input. No further